For this year's fall special, we're tasked with creating a water filtration system for a town nearby that's been swept over by a huge hurricane. We're only allowed to use a certain amount of materials in a 10 by 10 space. It's going to be 10 gallons of water, and they're going to mix Miracle Grow, salt, apple cider vinegar, vegetable oil, oats, yeast, and Hawaiian punch into it 24 hours prior to us filtering, and then 5 minutes before we actually have to filter it, they're going to stir it again so we can actually pour it through the filtration system. It's going to be tested for pH, turbidity, density, electrical conductivity, and dissolved oxygen content to make sure it's a good filtration. I'm going to now hand it over to my friend Frank.
Okay. So considering the challenges that were presented from the scenario, we prioritize on the purification of water through its pH level being relatively around 7, alongside having a final volume that has 9 gallons of clean water out of the 10 gallons of dirty water that we're going to initialize with. Now, firstly, we've established connections with our fellow engineer peers to come together as a team. Firstly, we've designed a lab report together to establish the guidelines for our prototype filtration. Once we created afterwards, we've created the filtration prototype and executed experiments to learn and expand our knowledge through trial and error. As a result, we are discovering the best method to purify the dirty water alongside maximizing the flow rate. Now, I will let my fellow engineer peers to discuss the construction and design of our prototype.
This is our filter system. These are the buckets that are going to be used. The reason we chose these buckets over any other ones because they were cheaper, and cost efficiency is a big thing in this competition. Another reason is the bottom of these buckets has a ring for you to cut a 2-inch diameter for 2-inch PVCs. And we have a threaded coupling that is 2-inch diameter as well, going in here and connecting the bucket to the filter system. This pipe right here is the connector from the threaded coupling here to the threaded coupling here that connects to the PVC. And this is where the dirty water will be loaded, and we have a screen for the top of this bucket that will filter out all solid waste before the water actually enters the filtration system.
So with that being said, once we move into the transition of this middle pipe right here, this is what our filter is actually going to be in. The filter consists of all things of activated carbon, sand, gravel, and what we use to keep that filter in there is actually just some fabric that's allowed on the process. And we use these threaded couplings that we have to actually put the fabric in and screw down on it, and then load all of the filter things into the pipe. The reason why we chose to do this was so that way we could actually maximize our time during the competition. So while me and my partner here are building all the PVC, getting it put together, putting the frame in, we can have our other teammates utilize their time and try to fill these and actually prepare the filters at that time being. So then we go down here to this bottom section. It's a Y piece that we designed so that way we could easily filter it all into one singular extraction system. It also helped us cut down a little bit on the PVC pipe cost because then we don't have to have 2 pipes going down, and we also don't have to have a second bucket to collect it in. It also helped a little bit on the weight that's going to be allowed on the structure for the wooden structure that we built. And then other than that, that is the whole system that we have designed for this process today, and we hope that we do well on competition day.